Boom. What up, math nerds and mathletes? Coach Murphy here for another exciting edition of factoring. I know there's not much more. There's not anything more exciting than factoring. I mean, actually, we know that's a lie. Okay, but there's no live sports on television right now. So, man, what's more live than factoring? What gets you hyped more than factoring? Well, how about factoring when there's an actual A variable? Boom! Yeah, that's what we're going to get into today, right? So, buckle your seatbelt. We're about to get crazy.
Okay, that's geometry. We're definitely not doing that. All right, so you're like, what do you mean in A, right? So we know, right? We know that in the past, we've factored when we've had x squared plus bx plus c. And when we've had a term right there, we've just kind of done a greatest common factor and pulled it out. Well, what if you cannot pull out this a, right? What do we do? Glad you asked. Steps to factor with an a. Okay, so we're dealing with ax squared plus bx plus c. Okay, first step. Take a to the end of the trinomial and multiply it by c. Okay? Then we simply factor the new trinomial. All right, now we cannot forget about that a. Okay? We have to then take that a and divide it, or divide the new factors by that original a term. So divide both your factors by the original a term. I know this is exciting stuff, man. Pace yourself. If you guys are feeling like you're getting overwhelmed because it's just so exciting, stop, take a break, grab some water, rehydrate. Okay? Next step. Yep, there's one more. There's a fourth step. Fourth step, reduce the fraction. Right? So reduce the fraction. If you have a denominator, like say you can't divide a evenly back into the new factor, right? You put it next to the variable. Okay, reduce the fraction, and then place any denominator. That's the bottom number, right? The demon downstairs. I'm not even joking. When I learned this, my teacher told me the denominator is the bottom one because it is the demon downstairs. Now, who tells a kid that? Now, teacher, she was awesome. I always remember to this day, right? So she must have been doing something right. Let's look at some examples. I know that's what you guys are waiting for. You're like, let's put this into practice. Let's get after it. I just like in wrestling, man. I'm showing a move, and then like everyone's like, let's just do it. Let's do it. Let's get after it. Okay, let's get crazy with it. So we have 2x squared plus 5x plus 3. We look at it and we go, can I take that 2 out, right? We have that guy right there, that a term. Like, can I take it out? Well, no, we can't take it out. So what we do is we take this 2. We then multiply it by that number. All right, and that leaves us with x squared plus 5x plus 6. Okay, now we're going to factor it like we've done before, right? We have to find two numbers that add up to positive 5 and multiply to positive 6. I know, the suspense is killing you guys. I'll save you it, right? It's going to be positive 3 and positive 2, okay? So we then put it in our factor form, so x plus 3 times x plus 2. Now, we can't forget about that 2 that we multiplied by 3. We now divide it back in. So we divide each of these terms by 2. Okay? If the 2 can be divided evenly, like there's no remainder, back into the factored numbers, then we leave it as such, right? So this can be divided back in, right? But this one can be divided back in, but this one cannot. So we take this number and we put it up right there. So we end up with 2x plus 3 times x plus 1. Right? That makes sense? Let's look at one more. Let's look at one more. So that way you guys are focused. Okay, so let's look at 12c squared plus 11c minus 5. First we look, is there a greatest common factor we can take out? No, there's not. So the next thing we do is we take this 12 and we multiply it by that negative 5, leaving us with c squared plus 11c, made a little mistake there. Like my main man Bob Ross used to always say, there's no such thing as mistakes, just happy accidents. Right? I'm not happy I made that accident, but hey, it happens. Right? We then multiply 12 times negative 5, give us negative 60. Okay, now we're just going to factor it. We got to find two numbers that add up to positive 11 and multiply to negative 60. I know you're racking your brain, you're like, I know what it is. It's positive 15 and negative 4. Excellent job. So we go ahead and we put it in. C plus 15 times C minus 4. Now, we cannot forget about our friend number 12, right? He has to be brought back into the picture. So we divide each of these by 12. Before we divide, we need to simplify. Always simplify fractions. So we're left with C plus 5 over 4 and C minus 1/3. Okay, since the denominator cannot be divided equally into the numerator, we're going to take it and place it in front of the variable, leaving us with 4c plus 5 times 3c minus 1. Okay? Simple enough. Now you're thinking to yourself, all right, Coach Murphy, what about if I'm going along and I get a problem that I can take a greatest common factor out, but I'm still left with an a term? Well, that's a phenomenal question. Okay, so let's look at a problem like that. So we have 10k squared plus 75k plus 35, right? So we got to look and see what number can I take out of every single one of those. And you guys being brilliant, genius mathletes and math nerds, you know that you can take out 5. Right? You're like, well, these end in 5s, that ends in 0, so I could take out a 5. So we put 5 out here. We're left with 2k squared plus 15k plus 7. Now, we still have that 2 in front of the k. We still have that a. So we take that a, and we multiply it by c, right? And that's going to give us 5 times k squared plus 15k plus 14. Right? Now we just factor like we normally would. So we got to find two numbers that add up to positive 15 and multiply to positive 14. What two numbers do that? Start going through. Oh, pretty simple. It's positive 14 and positive 1. Okay, so we now have 5k plus 14 times k plus 1, right? Now, don't forget about our 2. We got to bring that 2 back in. So we got to divide it by each of those, right? Well, 2 goes equally into 14, so we'll be okay there, but 2 does not go into 1, so we need to put it right there, leaving us with our final answer, 5 times k plus 7 times 2k plus 1. Okay? So, not that difficult, not that much more complicated, just a couple extra steps. Always remember to simplify your fractions, right? And you can check your work if you're unsure by distributing. Okay, so that is how we factor trinomials when there is an A term. I know, super exciting stuff. You guys are all pumped up. Try to relax, one problem at a time. All right, any questions come up, leave it in the comments. Let me know. Get after it. Stay on that math grind. I'm out.